Okay, we're looking at some related rate problems. We have the radius r of a sphere is increasing at a rate of 4 meters per second. What is the rate of change of the surface area when r is equal to 3 meters? So the rate of change of the surface area, and I think I'll label this as S for surface, and so this will be ds over dt. So that's what we're going to be looking for when r is equal to 3 meters. And then we'll come back to this part of the problem. This is another part, second part, or a different problem. Anyway, so we're looking at this. We're looking for ds over dt. Let's see. Let's remember that this is 3 meters, and the sphere is increasing 4 meters per second. Okay. All right. I started with the volume here. And remember, we were looking for ds over dt. But I just wanted to show you something here. I took the derivative of the volume, which with respect to r here, which is dv over dr, and that's going to be a 4 pi r squared. Now it turns out that this is actually what we're going to be using to find surface area. S being my surface area is equal to 4 pi r squared. Now, right, so if you can't remember what the formula is for finding surface area of a sphere, just remember to take the derivative of the volume, and there it is. But this is what we're going to be working with right here. So we go ahead and take the derivative of this, and so we end up with ds over dt is equal to, and then the derivative, right, of 4 pi r squared with respect to t, or taking the derivative of r with respect to t. So we take the 2, bring it out front, we have 8 pi r, and then we tack on a dr over dt here. And then of course we just plug in everything that they give us. So we've got r is 3, dr over dt is 4, and we end up with 96 pi meters squared per second. You can plug that in the calculator, approximate it if you want, and to get at least an idea of what the heck that is. But alright, well, let's look at the second part to this problem, or the second problem, I guess. So we have find the rate of change of the radius, so dr over dt, when the rate of change of the surface area is ds over dt. So this time they're giving us the surface area. And we have S, which is the surface area, is equal to 4 pi, and let's see if we're going to need that or not. Alright, well, let's go down there and take a look at this then. So we're looking for, remember, dr over dt. Alright, so we started with this. S is equal to 4 pi r squared, right? That's the formula for finding the surface area. And what we're going to need to do here is once we took the derivative of this, ds over dt is 8 pi r dr over dt, we know what the ds over dt is, but we don't know what the r is. And remember, we're asked to find dr over dt. So they weren't giving us an r, but they did tell us that the surface area is 4 pi. And so now what we're going to do is say, okay, S is 4 pi, and then we're going to set that equal to, since the surface area is equal to 4 pi r squared, then we're going to solve for r in this problem, and we get r is equal to 1 meter. So now we're going to go ahead and take that 1 and plug it in, so now that we know what it is, and our ds over dt was 10, and we just solve for dr over dt, and we end up with 5 over 4 pi meters squared per second, but that shouldn't be meters squared. Let's change that. Okay, that was magical. So we just turn that right into meters over seconds. I don't know why I put meters squared there, but anyway. All right, well, let's move on to the next problem.